Hello my friends, today I will talk about this device here. It's a
strobe
used in forklifts to signalize that the forklift is running. It uses a
xenon lamp.
and it's very bright, warning of flashing lights. I will test it to show you. This xenon light is not the original one. I used a camera flash bulb to make it flash. It is expensive here in Brazil, this spare bulb, but it works. I don't know how long it will take to burn this light. Let me stop to blink here. But it's only to show how it works and try to do a schematic of it. There's a warning. Reduce voltages. Disconnect power and wait 5 minutes before servicing unit. Failure to comply could result in serious injury or death. Yes, it have a high voltage power supply to glow, to make it glow the xenon light. So let me open it. Here I made the adaptation with an old camera flash unit. It's a straight lamp, not a lamp in U-shape like it's the original of it. Like this. It was made in 2012, June 27. So it's old. I found it on a junkyard. This is a toothbrush cable. Let me see if there are hazard voltage really are, because there is a big capacitor here, a giant capacitor. Let me measure on it. Oh my god, 230 volts. It's coated, because of it it's difficult to make contact. Silicone coated. Oh, there, 150 volts. Let me use this adaptation that I have. It's a multimeter with a lamp in parallel. A microwave lamp in parallel. It will discharge the capacitor here. It will be safer for me. Let's double check it if there are voltage here. Okay, 8 millivolts. Now it's better. It's very nice to see the circuit of it. The consumption is about 200 milliamps. There is a 555 here, oscillator, I see. This is the high voltage transformer. It is a MOSFET to switch the high voltage to the bulb. That is here. Some filtrations of the input. The input voltage of it is 12 volts to 8 volts DC. It's showing here. Industrial think with a 555 oscillator. Very nice to see. It is a very robust IC. Some inductor here. This inductor, I think it's filter. Some transistor here. I don't know. I think it is used for the power supply. I think it is a Xenon Xenon diode to make a power supply here. I don't know. I have to do the schematic. I really don't know. So I try to make the schematic. A high voltage is created in the ends of this bulb. Say a trigger voltage is sent to this contact on the middle of the bulb and the plasma glow, conducting the plasma here inside. It's more or less it. Okay, you try to do the schematic for you. I think it's a vestor. No, it's a capacitor. C2. Okay. I think this is the vestor. Yes. This red thing here is a varistor. So here is the schematic of the strobe. The battery plus positive, it pass through a fuse and a diode and a inductor filter and a varistor. VCC will be utilized in another part of the circuit. The DC voltage is filtered by 33 microfarads 160 volts electrolytic, and the voltage is regulated by a transistor, NPN1, with the use of a Xenon diode. This resistor limits the current in the Xenon diode, and this transistor regulates the voltage to the 555, because the range of the supply voltage is from 12 to 80 volts. Because of it, there is this simple transistor regulator. The 555 works in a stable mode. The output will be a frequency, fixed frequency. This capacitor, I didn't put some values because there is coating here, silicon coating. It's too difficult to take out the component and see, because of it I omitted the values. I will measure the frequency of the output here. This controls the frequency, this capacitor, these resistors here, and that is it. It's a simple stable 555. And this varistor, I didn't found any information about it. The fuse, I don't know the value because the coating too. I prefer not to take out and take a risk of crack the fuse or something like that. This output goes to this, a MOSFET, a ERF720. This with this inductor through this diode, and it pumps this 450 volts capacitor to charge it, and prepare the xenon lamp to conduct, because it conduct when high voltage is applied on the center terminal of it. So it pump the voltage here in the extreme pins of the xenon lamp, and this little transformer here makes the high voltage switch on the lamp to make it glow, forming a plasma. And this frequency is controlled by the 555. So the strobe begin. Here we have an anti-parallel diode and a rectification diode. I think it's Schottky diode, but I didn't find any information about these two. This I don't know the name because it's completely glued. I don't want to crack it to damage, only to see the value. This transformer I don't have the information of it because it's only a black box, like you can see here, only a black box without any inscription. This is the transformer, this black box here. So it's basically like this. The frequency came here and pumped this capacitor to charge up to 450 volts, and this at the same time charge this transformer to make high voltage and switch on the lamp every time the strobe. It is how this circuit works. So I will measure the frequency here, and this part I don't want to take a electric shock here. So let me prepare the other thing. It's how I made this xenon lamp. It's a toothbrush piece of a plastic, and 3 holes and 3 pins, and it solder the pin into the extremities of this light bulb, and in the center of it there is the trigger terminal of the xenon lamp. Okay, and it is put here like a connector, and there is a 2 screws here. So the frequency of the 555 output is 13.6 kilohertz with amplitude of about 10 volts. This pumps the charge of this capacitor and the high voltage transformer. And took a measure at this VCC of the 555, and it's about 9.7 volts. And this Zener diode is 10 volts. 10 volts Zener diode. So the frequency that the xenon pumps the light, the light, is about a hertz, 1 hertz. But sometimes I don't know if this is the effect of the non-original xenon lamp, but sometimes it don't have the right frequency of blinking. Sometimes it take another value of frequency. You see it by the strobe. The value of the blinkings, the frequency, is made by this capacitor with this resistor and this diode here. I think it's not a diode. It's kind of diode or something like this that pass the voltage after a certain level is reached. Like when it's 10 volts, I let it conduct, and it make a pulse here, like this. So the frequency generated by the 555 and this circuit here makes the blinking frequency of the strobe. And this resistor here let some calculated current pass here to charge to this capacitor. And at the same time, with this other resistor here, it make a RLC oscillator, because the inductance of this transformer, it is a RLC oscillator formed by this circuit here. I'm measuring these 2 points, the primary of this high voltage transformer here, and these are the pulses of the and these are the pulse of the trigger, the pulse of the strobe. It charges the capacitor, and with this generates this pulse. They are kind of a second each pulse. So thank you for watching. Give me likes and support me. Thank you. Thank you.